Our next lecture will discuss global objects, global variables, and how to start and stop contracts. I have used files that are already on the CBC2020 repository, right? So start-stop.sol, and the basic transaction contract name tokens. So take these two contracts and essentially deploy them on your Remix integrated development environment. And let's take a look at the basic transaction first. What happens is that we have a contract name tokens. For this one, I'm using I set compiler 0.5.13. We create an integer that is holding the balance received for the contract, and then a function that essentially receives money, is public, and is payable. Remember that you need to declare that a function is payable if you are to receive money from the outside. And essentially, then we declare that the balance received should increase. This is the plus equals, should increase as much the value of the value sent with the transaction. So what essentially this says is take a look at the value attached to the transaction that is being sent to the contract and increase the balance on the contract by that amount. The methods.value is a global variable, and if you go to the Solidity documentation on units and global variables, you'll see there is a number of them that you don't need to declare them in every contract, but exists anyway within the EVM. For example, methods.sender, this is the center of methods, and a lot of times we will use it as an address to establish who will need to receive a certain value, and that will be the address that sends a specific transaction. Methods.value is the number of ways sent with the methods, and methods.data is the complete call data that is sent again with each of these messages. Be careful that the transaction tx.gas price, again, is a uint, is the gas price of the transaction. There's a difference between the gas price of what the computation will take and the number of ways sent with the specific methods. So methods.value here is in way, and this is what we're sending to the contract. And we also declare another function, which is the balance of the contract, and this essentially returns another uint with the balance of the contract. Another function here declares that we can withdraw money to the address that called the contract through the methods.sender properties, right? So essentially, I can withdraw money not to anyone, but specifically to the address that constructed the contract in the first place. And then we have a third function, which essentially allows us to withdraw money to a public address that should essentially be the one that to a third one that is declared here. We haven't declared it yet, nor have we used the methods center. So let's see what happens here. So first of all, let's check the state of the state of affairs, right? So balance received is 0 and 0. Let me change to address with 100 Ether change my unit to 100, and I will send them 20 Ether. And you see that the transaction has been mined. And sure enough, if I check balance received and get balance, I will get 20. If I ask to withdraw money, I get almost the same amount back, and the balance received still remains 20. But if I check the current balance, which is the get balance variable, the number is 0, and with the withdraw money, this has been returned directly to the contract over there. Let's try it again. I'm going to put 20 Ether, 20, not 200. Receive money. The current balance is 20. And the balance received, obviously 2 times 20 is 40. And let's attempt to withdraw money to a third contract address, to a third address. Address copied. And I want to withdraw everything to this one. And sure enough, I was able, through the contract, to make a transaction between these 2 addresses. So this is the value of the methods.value and methods.sender global objects, because they allow us to very succinctly declare values in a transaction or addresses in a specific originator of a transaction. Let's go and take a look at start and stop, continuing from this. As we've said, the blockchain is immutable, so essentially you cannot delete a contract, but what you can do is you can start it and then pause it. So, and we should be careful essentially to allow only the controller, the person or the address who has actually created the contract, to do that. So the contract here is called start stop update. I declare the address of the owner, and I initialize a Boolean variable which is public, and I named it paused. The constructor is a special function within smart contracts and essentially initializes the contract and is called only once. And within this one, we essentially assign to the address of the owner the address of the sender of the transaction by using the methods.sender. Essentially, this sets the owner of the contract as the sender of the transaction that will initiate the contract. And then we have function set paused to trigger a change in the pause of the contract. And then we provide a requirement to say it is required to execute this only if the sender of the trigger is essentially the owner. And if we have someone else triggering the contract, we will receive the message, "You are not the owner." And further below, right, we have still the function of sending money and withdrawing all the money, but also 2 further requirements. One is that you are withdrawing the money only if you're the owner, with setting message.center equals the owner, and also that the contract is not paused. So you see that in certain cases, you need to still declare that the contract stops behaving. And you can destroy the smart contract again by setting a self-destruct transaction through the function destroy smart contract function. So essentially what we're saying here is that, and I've noted that at least when I was trying it, the destroy function did not work because you need a complete transaction here, not just a simple one. So take a look at start stop update. Let me first check if it's paused. No, the boolean says it's false. Let me send some ether first. I'll use the fourth 10 ether. Send money, and I will try and take it back by copying on the clipboard. But what happens is I did not use the address that has created the contract, and essentially whomever sends money to this contract will probably lose it. Let me take it back to the contract. Sorry, to the address that did create the contract. Let's see if it will work. Or probably I cannot remember which one I used. Yes, it was the second one. And you see now that immediately I get the 10 ether back. And if I try to pause, it actually takes place. If I try to send money to the contract, it does take it in, but I'm not able to retrieve it back, which means that I will need to complete correctly the self-destruct option.